are here to talk today about the shifts in the Common Core standards and a little bit of help for you guys as parents as far as homework goes. I'm Jillian Balistreri. I'm a 5th grade teacher here at the Galvin. I teach math and social studies and reading.
And I'm Wendy Phillips. This is my first year here with Wakefield. I'm the 5 through 12 math curriculum coordinator. And I teach one class here and work with the teachers here and at the high school. All right, before we start, I do want to say that we are educators, and so we're going to be presenting this from the educational perspective. I know there's a lot of controversy around the Common Core standards. I happen to believe in them strongly. I think they're a good move. I think there's going to be a little bit of rocky road, but if we can just keep it to the educational perspective and away from the political, we would appreciate it. And now, as we go through, I'll be sort of presenting you with some information, and then Jill will share how that looks in the classroom and ways that it might impact you. So first of all, just to clarify, so the Common Core state standards are national. Massachusetts adopted them and based the Massachusetts curriculum frameworks on them. And one of the slides, you'll see the places where Massachusetts tweaked the standards a little bit. So we do actually follow the Massachusetts curriculum frameworks, and they're based on the Common Core standards. So the standards they're research and evidence-based. So there's what I'm coming to understand is they've really taken a lot of time to look at those difficult to teach topics and kind of divided it up among the grade levels where it's appropriate to teach it, teaching them a little bit at a time, and you'll see that as we go through our presentation. The second thing is it's aligned with college and work expectations. So our current standards really only went up through 10th grade, and it wasn't necessarily a college readiness. I teach a course at North Shore Community College, and I see the impact of that. I have students that are in college, sophomores in college, that are having difficulty with 6th grade work that I bring in. So what that means for those students is that they're taking remedial courses, and those courses are not covered by scholarships. They're additional costs. So by meeting the Common Core standards, it's actually a cost savings. Students develop a deeper understanding of fewer topics, the rigorous part of it, and we'll be talking a lot about that next year. And then because the standards are internationally benchmarked, it allows us to better compare ourselves to other countries and be competitive in the international market. So really, we're going to be talking about these shifts, how the standards are different from our current standards, and there's several categories we'll talk about. So the focus has shifted, and we'll go into this in more detail, but just to give you an overview at this point, the focus is now a narrower and deeper focus on prioritized standards. And what that does is provide a really strong foundational knowledge. There's more coherence in it. There are really well thought out connections between not only grades, but not only between topics in a grade, but between grades and between other subjects. Fluency was added as one of the new standards. Deep understanding, so it's more about more than how to get the answer. Application, so it's a lot about taking the math and applying it to real world situations. And then a balance of what's called practice and understanding. And I apologize for how small this is, but I will tell you at the end we're giving you a brochure that summarizes these key ideas. So the focus at each grade level. In kindergarten through 2nd grade, it's addition and subtraction, concept, skills, and problem solving, and place value. So that's the focus of the standards at that grade level. 3rd through 5th, it's multiplication and division of whole numbers and fractions. Again, concept, skills, and problem solving. You're going to see that repeated throughout it. 6th grade, ratios and proportional relationships, early expressions and equations. So they're starting with some of the algebra. And actually, you'll see when we get to there's a chart that actually algebraic thinking is even into kindergarten. 7th grade, ratios and proportional relationships, arithmetic of rational numbers. 8th grade, linear algebra and linear functions. So those are the focus of those grade levels. At the high school, things are a little bit different. So at the high school, there's conceptual categories, and those conceptual categories are broken down into courses. And districts had a choice on how they wanted to break those categories up, there were two different choices. There was a traditional pathway, which is what we're historically used to, and then there's what's called, I think it's model courses, where they kind of integrate everything. Wakefield decided to stick with the traditional pathway, and the traditional pathway is Algebra 1, Geometry, Algebra 2 at the high school. So those recognizable course names still stand.
So as far as the focus looking for the students, they're going to be spending more time on fewer topics. So as teachers, we have less to teach in a way so that we're able to develop that deeper understanding for the students by focusing on fewer things that make sense. And then they will be able to take that deeper understanding and apply it to multiple problems and applying multiple skills to multiple problems. So they're really seeing how things are connecting. And I think that is really helpful for parents as well, because then if you focus on just those key areas that we showed, you're helping to develop and ensure that those foundational skills that the kids need as they move through the grade bands and move through the grade levels. So there's almost like certain benchmarks that they need to be hitting before they move on to the next grade, and it keeps them from being behind, which I'll get into a little bit later. And then being able to help as parents, sometimes the easiest thing you can do for kids if they just need help with their multiplication facts. You can do a simple drill and kill. They're practicing their facts and making sure they know those automatically. And sometimes it's just as simple as having them talk about the math a little bit more. And talking through their solutions maybe on their homeworks and things like that are the best things that parents can do.
All right, so as far as focus goes, so this is the chart that I was talking about before, and this actually comes from the Massachusetts curriculum framework, but they are aligned to the Common Core standards. Where you see the shading going on is where that domain is taught, and you can see how it really progresses through the grade levels. So we start with counting and cardinality and pre-K and K, and where you see the MA is where it's specific to Massachusetts. So Common Core does not include pre-K standards. Massachusetts added the pre-K standards. And then there were a few added into 5th grade, and there's also some in 6th grade, I thought, but I'm not sure why that's not listed in.
And I can speak to the 5th grade. They don't typically see negative numbers in the 5th grade, and as far as the Common Core standards go, but within the Massachusetts framework, they're seeing them a little bit earlier, and it's in a very generalized way. So it's thinking about like above or below sea level, a credit in a bank account, a debit in a bank account, and that just helps them to be able to be a little bit familiar with it before they start doing the operations with them in the upper grades in 6th, 7th, and 8th grade.
What's the different shadings?
So the different, I think it's just to show the different grade levels. That's my phone. So that's where they actually work on those topics. So if you look at counting and cardinality, that's pre-K and K. In operations and algebraic thinking is pre-K through 5th grade. And then we add on operations, numbers and operations in base 10 starts in kindergarten through 5th. And then build on that with number operations and fractions in 3 through 5. So it's really well thought out as far as the progressions and the focus. Having taught under the old standards, all of these categories were every single grade. So it was, they call it mile wide and inch deep. And you were floundering. So it's really, that focus at each grade level is so key to it. So this kind of shows you again that the coherence, like I said, not only within the grade level, so fewer topics within the grade level so that we can really focus on it. But then really thinking through how those things need to build, how the topics need to build on one another, and how that progresses. So for instance, in 6th grade, actually I'm on the wrong slide. I'm going to go back to that one just because I want to talk about that. So within the grade level, the coherence, in 6th grade, students learn about median. So they learn how to calculate a median. Box and whiskers plot is a graphical representation that requires them to calculate the median 5 times. So and that used to be an 8th grade topic. By moving it to 6th grade, you're able to learn a skill and then apply it to something that they can represent in real life. In 8th grade, they learn the Pythagorean theorem, and then the volume of a cone is an 8th grade standard. And they can use the Pythagorean theorem. If they're given the slant height of a cone and the radius, they can use the Pythagorean theorem to find the height, which they need to find the volume. So it's really tying those topics together in a very well thought out way. And that's just a couple examples. So in this one, this shows more the thinking across grade levels. Learning is carefully connected so that students can build new understandings onto the foundations built in previous years. Each standard is not a new event, but an extension of previous learning. So for instance, 4th and 5th grade does their work with numbers, operations, and fractions. Well, fractions are really just ratios and proportions. So we focus on the fractions in 3rd through 5th, and then extended into ratios and proportions in 6th and 7th. Proportional relationships are really just linear relationships, and that ties into their learning in 8th grade and into algebra. So when you really start to focus on how those topics have been thought out, it's a very well thought out sequence and progress.
But here statistics is listed under 6th grade, if I'm reading it correctly, and the previous one was high school. No, 6, I'm sorry.
Yeah, 6, 7, and 8. There is also statistics in high school. A lot of where the changes are is more in the elementary to middle school, where we stayed with the traditional path. The high school tends to look a lot like it used to look.
All right, so with this coherence, as Wendy has said, that they're just going to keep building on these concepts. So it's important for parents to make sure that if they do have any gaps in their learning, that those are being closed, maybe with summer work, with a tutor, with extra practice at home, whatever it is that works best for your child. And I think with this carrying on of skills, that if there is something that they did a nice job with, maybe say in 3rd or 4th grade, when they get up to 6th and 7th grade, knowing that they have that confidence in themselves about that, and even just being able to see these connections helps them really own the math. And I think that is one of the hardest things for kids to do, but I think with that, they're able to persevere through problems that they maybe wouldn't have before if they didn't feel confident in something, or if they weren't seeing that connection. Because when they're learning something new for the first time, it might seem completely out of nowhere to them, when really there were these foundational skills. And pointing those things out to your students too, and seeing that, remember when you were in 3rd grade and you worked on this with your teacher, you can use that now in 5th grade, 6th grade, wherever they are. So I think a summer, even just spending an hour or more a week can be enough. And like I said before, it could be as simple as the drill and kill type stuff, or being able to just talk about math and just making sure that before they move on to that next grade level that they're ready, and really focusing on those few skills that we mentioned before, so that they're not falling behind with these new topics, when they could simply just make sure that they are better at their multiplication facts. So when they do get to simplifying fractions and comparing fractions, they can do that more easily.
And I would say those focus concepts, freshening up on them towards the end of the summer, so that when they come in, they're ready to make those connections into the new topic. We do that as teachers as well, but it can build their confidence a lot to come in remembering. So this is one of the huge ones that I'm really happy about, is in the standards and was not in the previous standards. They have defined fluency, and by fluency, they want them to be able to automatically be able to calculate using standard algorithms. And that, like I said, that was not in the previous standards. So depending on the way that the teacher may be taught to do multiplication, or the way the materials focused on it, you could have kids coming up doing all kinds of ways of multiplying, which is great because then they really understand it, but never getting down that standard algorithm. So this is one of the ones that I'm really happy about, is in here. And just to go through it, and again, this one is on that brochure as well. In kindergarten, the required fluency, and these are tested fluencies, is to add and subtract within 5. 1st grade, add and subtract within 10. 2nd grade, single-digit sums and differences, sums by memory by the end of the grade, and then being able to add and subtract within 100. 3rd grade, single-digit products and quotients, so multiplication and division, and then add and subtract within 1,000. 4th grade, add and subtract within 1 million. 5th grade, multi-digit multiplication. And 6th grade, multi-digit division and multi-digit decimal operations. So you can, again, see that progression and how I would say, well, actually, I wouldn't even say that, just that one, but how if they don't master one, how it's going to kind of snowball and why that's so important. So Jill will talk more about that.
And those are what are the must knows. So those are the things that they need to know before moving on to that next grade level. And this is where that, what I keep saying, that drill and kill method, they just need to practice, practice, practice. And I'm sure you guys are probably used to the time tests. I know I had to take them. I would cry when I wasn't finished with all 30 of my problems. And we don't tend to do that in the classroom so much anymore, where we are really focusing on that deeper understanding. But that's something that you guys can do as parents. And I know that a lot of this thinking, this new thinking surrounding math is difficult for students and difficult for parents, but this is where you guys can shine because it's exactly what you did. Those traditional standard algorithms that you're used to, when they come home and say, that's not how my teacher showed me how to do that. And you can say, well, this is the way. It's the one way that you know that you guys can help them with, that they'll know that they're getting that right answer. And really, it's just time practicing. And I know they're probably going to hate doing it, but to keep them so that when they are trying to do the deeper understanding on these next topics, they really have just those simple skills that really need to be automatic. I tell my 5th graders all the time, if you can't tell me what 6 times 5 is in 10 seconds, you need to be at home practicing your multiplication facts. And I always tell them, I said, when you're brushing your teeth, just go through them. Do what 6 times 1, 6 times 2, keep going, and just until you know that you can automatically tell me 6 times 7, 3 times 12, whatever. They need to know those automatically because otherwise it'll be a hindrance to them when they're doing these deeper topics with the addition, with decimals or multiplication of decimals when they're doing the long division. All of those things need to be automatic. Otherwise they'll get hung up on those little steps and then they'll end up falling behind. Do you have a question?
Yeah, is that you were saying that there are few ways to explain how to do things.
Right.
And for me, I don't know for other parents, we know the old way.
Right.
And try to explain to a kid, for example, for a test, how to do certain operations is hard. Because you're trying to simplify the way, but they have to also to learn on this new way of grouping or doing this in this
and they're seeing both ways typically in the classroom. They're seeing that standard algorithm depending on the grade level. They might see it later after they've done that, where they have to talk about it in a certain way to try to develop that deeper understanding, so that they're seeing why when you carry the 1, what that means about as far as tens and ones and place value. So that's why both of them can be used hand in hand. And I know that.
But they have been teach a lot. I like it both ways. I hope so.
Yeah.
Because again, it is hard trying to. Well, you notice that they spend so much time doing something that they could do it quickly instead of.
Right. And
we'll
talk more about that too as we go through because we know that's the common frustration because we didn't learn this way.
Okay.
So we're definitely at a disadvantage.
Sorry.
So no, that's fine. That's fine.
That's a good question.
So the next one is the application. I think we have time if you want.
So this would be an example of a problem that they might see on a test in the classroom or on a standardized test. So I'll read through it if you guys want to read along with me. So we have John and Daniel, and they're eating a lot of pizza. John ate 1/4 of a cheese pizza, 3/8 of a pepperoni pizza, and half of a mushroom pizza. Daniel ate 5/8 of a cheese pizza and the other half of the mushroom pizza. So all the pizzas were the same size, and John is saying he ate more pizza than Daniel because Daniel didn't eat any pepperoni. But Daniel says they ate the same amount of pizza. Who is correct? And show all of your mathematical thinking. So it's that what you guys would be able to easily answer with your background in math would be who is correct.
Actually, why don't we do that?
Yeah?
Yeah, why don't you take a few minutes and see how you would answer that.
And then we have an
We're not going to come
example.
around and correct or
Yeah.
anything, so no pressure. But just to see how you would do it, because we have a student example coming next.
And just some hints that I would give my students, we talk about the hidden questions. So the things that aren't there in the problem that you need to figure out to be able to come to that solution. So these are these multi-step problems that they're going to see over and over again, that there's not just one thing. You don't just have to add a couple of things and get the answer in this case. There's multiple steps to this, and those are those hidden questions, we like to call them. If anybody needs help, I'd be happy to come around and help. Well, that's the answer to the question, how much they eat, they eat enough to give themselves a bellyache, is what I would tell the kids.
Small pizzas too, it's just some size.
They're actually extra large, extra cheese pizzas.
You look a little sleepy.
So why would you want to do that?
Do math, and then what they wanted to go.
Right.
So this one's here to add up.
So that's what all students think too. But actually fractions are easier than decimals. And one of the shifts in Common Core is that they suggest you introduce fractions before decimals, because decimals look a lot like whole numbers, so kids just gravitate to them because it's what they're familiar with. And fractions, most times.
Understanding of the students. But you did repeat a lot.
Okay. It was third, fourth, and fifth. I think there's fractions. Do they start in third?
Yes.
With, I think just
I think
the
it's typically like the
concept.
benchmark fractions, like thinking about what a half, a quarter, and then they would start adding them and comparing them in fourth grade, if I'm not mistaken.
Yeah, and then, yeah. Are we ready to see? So I see a lot of fractions, common denominators, adding them.
Picture representation.
Oh, we did have
so
pictures?
really good.
Okay. Wow. Because if you look at this, and I'll let Jill talk about
Sure,
it.
and somebody did ask if they should be writing all that information down, and that's what we tell kids all the time. Write down everything you know. We did little T-charts when we were getting ready for the park test to write down what you know on one side and what you need to know on the other side. So the things you would need to know for this would be the fractions of the pizzas, each pizza that they ate, and what you need to know, those hidden questions like I was talking about. You need to know how much John ate, and you need to know how much Daniel ate so that you could compare them. And so we can go through this student example there, which is a fantastic with this key that they have in here. So what they decided to do was draw this student to draw a cheese pizza, a pepperoni pizza, and a mushroom pizza, and they cut it into eighths. So that would end up being your common denominator if you decided to do it that way. And they labeled them for each person, and then they added the fractions. So they have 1 1/8 slices of pizza, which I think that should actually say 1 1/8 of a pizza, not slices. But on a standardized test, if they saw something like that and it was even just a mislabel, that wouldn't be completely wrong because of that, because they're showing their thinking. They're showing you that they knew the pizzas were split up into eighths, that they each ate a portion of the pizza, and they ended up, which I'm actually surprised by this answer because when I was looking at it very quickly, I didn't think it was the same.
It is the same.
It is the
Yeah.
same?
Yeah.
Then we had an incorrect conversation back there. Because what you did back here, she had 4/8 of all pizzas, but the mushroom, I believe it was, and 5/8 for the pepperoni and the cheese, but not the mushroom, and then that other half of pizza. No, I'd have to look at your work again and we can figure out where we went wrong on that one. So this, which they show that they were accurate. So this is getting closer to what we're going to talk about next, right? The practice.
Yeah, I think so.
Yeah.
I think it's
So they're accurate in that they were using the numbers from the problem and they were using the correct operations. They labeled everything. So again, that's showing that they were being careful about their work, and they made sense of the problem. And that's the biggest thing I'm always asking students when we're working on word problems is, does that make sense? So this one, when I looked at it and saw the slices, that wouldn't make sense because you know they ate at least half a pizza. So the label of slices wouldn't make sense in this context because you knew they were eating more than just the one slice of pizza. So that would be the one little error that I would have seen in this one.
So, and I'm going to go back to what you were talking about before because, I don't think a lot of us would think to go to this, but that is a big part of the standard is being able to model and make it look like real life. You get it?
Gold star.
And I understand that frustration of being able to help your child. So one of the things we are starting to implement this, it kind of came through a discussion that was a 5 through 12 discussion. So hopefully eventually it'll be permeated throughout. It's part of our problem solving plan that we developed. Having your child make one of these if they're stuck on a question. And all right, what do you know? And then what are they asking you to find out? Even if they can't solve it, you're going to see on one of the future slides, really it's not as much about the answer anymore as it is about the work. So the more, if your child's struggling with something, you don't necessarily have to get them to the answer, but have them, get as much of their thinking on the paper as you can. And for me as a teacher, that's what I'm looking for, is where are they stuck, what do they know, and where's the thing that's getting them stuck, because then I can ask them a question or kind of guide them to, a different path or a start of a path.
I have a question for our third graders are doing the park next week. And will they have, because I know they have to do everything on the computer, will they have paper and pencil to do this?
They do.
Chart?
They get
Yes.
scrap paper
Okay.
and
Yeah.
pencils,
To
yes.
do the-
And that's why we started talking about this,
Okay.
because we don't want them trying to do it in their head. We want them using the paper and pencil, and it's a transition. It's something that they need to get used to. So we are, aware of that and teaching them strategies to be able to do that. And like I said, as a homework tool, I feel like it's really valuable, because I always had my students, I said, if you're stuck on a problem, I will give you full credit if you ask me a thoughtful question. And a thoughtful question is, I know there's 5/8, 3/4, and 1/2, and I know so-and-so ate this much. I'm not sure what I'm supposed to do with these fractions in order to be able to figure out who ate more pizza. Because then I know they've read the problem, they've tried, and they're showing me, they're just not sure of the operation. It's not that they don't know how to add fractions or they don't know to make a model, they just aren't understanding where to go with it.
So eventually over their career, will they still be able to do the paper and pen as they're doing the the paper and pencil math piece, and then put it in the computer for the exam?
Yeah, so what they have on the paper pencil is scrap paper. They actually don't
Right.
have a copy of the questions.
Right.
And yes, it actually says in the instructions that the school is required to give them 2 pieces of scrap paper per section. And I administered the 8th grade, and I was handing out more if they needed it.
So that's
I
not
encouraged
going to
them.
go-
I said, I actually
Okay, good. 'Cause
did
that's-
a park introduction in Jill's class, and I told him, I want to see that scrap paper, not that I'm going to be looking at it, I want to see it covered, front and back, like the more you write, the better you do. So, yeah, and I think, honestly, it's harder for us because we're not as used to doing it. The kids, it does come more natural to them. They're more used to that technology.
And that's what I was going to say too, that it can be very hard for parents to see their child struggling, because I'm sure you get the same, I don't get that, I don't know what to do. Well, did you read the problem? Do you know what's going on? Can you tell me what you know? And that with that,
They start yelling.
yeah, I'm sure they, not at us luckily, but I'm sorry that happens.
You don't know anything.
And so that really being able to explain what they know, like Wendy was saying, giving them credit if they can ask that thoughtful question, even if they just write that on their problem. I know, hopefully, a lot of teachers would be like myself and say that they're showing that they're trying. And that's the most important, because of the deep understanding slide is coming, but because that is really such a huge focus, it is very heavy on word problems. And there could be students that are great at their computational skills in math, but being able to really look at that problem and decide, okay, I need to know this, I need to know that, I need to use addition, I need to use subtraction, that can be really hard for kids, especially kids that are maybe struggling readers or just can't get their brain around it. I know kids that are in the language-based classroom tend to have trouble with this type of math because it's not that their math skills are lacking, it's just that their language skills, their reading skills are lacking. So it's really important that they're able to, I always say we talk like a mathematician and we think like a mathematician in my classroom, and so that applies to these type of problems. And they try to do everything in a real world sense, and I tell kids, even if they're just simply adding fractions, I'm like, okay, think about it. What's a time that you might need to add fractions if you're trying to figure out how many pieces of wood you need to make a project, even if it's not an actual word problem. And that really helps their focus when it's just numbers to them. And I think it helps them to, again, own their math, which is so important. And I think it answers that question, why do we need to know this? And so being able to do the math that comes up in daily life, which is our suggestion here, have them help you with the grocery list and the budget for the groceries. Have them help you figure out how much paint you need for painting their bedroom, how much the area for their carpet.
Cooking.
Yeah, cooking.
Yeah.
Baking is
Yeah.
huge. If you like to bake, which I love to bake, and I use examples like that in my room all the time. That if I'm trying to make brownies for, I have a recipe for 12 people, I need to make it for 24 people, how do I double this, that, and the other thing? Those are all, anything you can think of. If you're doing a project with, you're using carpentry at home, they can help you know if you have enough wood, if you have enough materials, anything like that. And then it makes sense to them. It's not just numbers on a page, operations on a page. They really understand where it's coming from and why it's important. Because I know that's a huge question from kids, why do I have to do this? And then you can show them it's in your daily life and not just say, because you need to know it later. They have reasons for it and they can see examples of how it applies, even for really young kids, maybe figuring out how many baskets they need for all of their toys, being able to make those equal groups. Anything like that is huge for kids to really understand why they need to do it.
I would say even playing games, how many more spaces do you need to win? If you've gone 10 spaces and there's 15 on the board, how many more do you need to win? Talking about strategy, you can make it fun if you really start to focus on it. All right, so one of the things Jill and I were talking about beforehand is that as we talk, we're going through these shifts, that they're really a lot related. So I think you've heard us talk about this before, the deep understanding. So what we're trying to teach now is not necessarily how to get the answer, or not just the answer. We want to know how did you get there, and teaching strategies to get there. Students apply their core math concepts to new situations. So when they are able to take something they've done, adding fractions, and apply it to eating pizza, it just strengthens it, and it gives them that connection so that it becomes more important to them. And students are able to write and speak about their understanding. So some of the things that I've heard from parents are, little Johnny is doing great, he gets the right answer, and he's losing points because he doesn't show his work. Well, that's what we want to see, is the work. It's how is he getting there? And for some kids, and oftentimes these are the kids that are good at math, the answers just come to them, and they don't really know how they're doing it. So that's their growth area, is they may be comfortable with numbers and be able to think about them, but they're not really aware of how they're thinking about them and when they're doing. And that's really important when it gets to algebra, and it's not numbers that they can make sense of and connect to in real life. It's variables, and they really need that deeper understanding. I think the other thing is that idea of they're applying it to slightly different situations. So they may have problems on their homework or problems on their quizzes that aren't exactly like ones we did in class. They require the same skills, but they have to think about them a little differently. And I know, that can be frustrating. So it's a learning curve for the kids as well as you as parents, and how to support them, even as us as teachers, and being able to teach them.
And I tell them all the time when I'm like, well, how did you get to the answer? Well, I did it in my head. And I said, oh, well, I'm a 5th grade teacher. I said, I'm not a brain surgeon. I said, I can't look in there and see what you're doing. And they laugh, but then they think, okay, well, I need to write this down. Because I tell them, I said, if you have no work on this page, I can't help you figure out where you went wrong. We were talking about that problem before, that I can sit and look and say, oh, okay, you may have written down the wrong fraction here. Oh, you put your decimal in the wrong place. And then we're able to have that teachable moment where they're like, oh, okay, and then internalize that and not make those mistakes again. But if they just did it in their head, I said, there's nothing for me to look at. There's nothing for me to help you with. And I know that this is the absolute hardest thing for parents, because I know, and especially that wait time, it's hard in the classroom too, that I'll put a problem up on the board and say, does anyone know how to solve this? And they'll just look at me. And they're waiting. Well, she's going to eventually tell us what to do. And I said, no, well, we're just going to sit and think about it. And sometimes it can be painful standing up there for a whole 60 seconds while they're thinking of it. And I know when they're working on their homework, if you're sitting with them and you say, well, think about it, and you wait that 30 seconds, 60 seconds, a minute and a half, they're like, well, aren't you just going to help me? But they really need time to think about it. And I think talking about it is the best thing that they can do. Like we were saying before, telling you what they know, what they can figure out. Oh, this might have been like a problem I did before. Oh, I remember what we did in class today, and really just give them the time to process it. And it's hard. I will tell you, it is hard to sit there and just stare at them like they're staring back at you and waiting for them to come up with some connection that they can make to something that they already know. But that's the best thing for them, because then when they're making those connections themselves and we're not just giving them the answers and reminding them of the steps, then they're really owning it and making it their own, and then being able to apply it later.
I think the other thing
go ahead.
Sorry. The other thing you can do as parents is when they show you their homework, if there isn't a lot of work on it, ask them, how did you get this answer? What did you do? Why don't you write that down? Even if they just verbalize it to you, being, kind of requiring them to do that is something that you can do to support. Did you have more on this?
Yes. And so that notice whether your child really knows why the answer is what it is. there's a section in the program that we use and it's called Prove It. So it's explaining that I know I had to take this fraction and add it to the other fraction because it was a part total, or I know that I had to subtract because they were looking for the difference between two numbers. So really being able to, as I said before, talking like a mathematician. We have a contest going on in my room constantly that the kids are using their vocabulary and they're using it out loud and they're using it appropriately and being able to explain and not just shout words at me, which happens too sometimes, but that they're really able to know what they're talking about and not just repeating stuff. Because I know even when I was a student, that's what we had to do. We had to just, you did this problem and you did another 2-digit addition and you did it again and again and again and again and then you learned it. But this is being able to explain why you're adding the tens and the ones and anything like that.
Okay, so I know this slide is overwhelming and what's in black is on the brochure, but this is really the one. I talked about the fluencies being a big shift and being happy about it. This is another big shift. So we in Massachusetts, before Common Core, had standards, content standards. We still have content standards that are aligned to Common Core. Common Core also has what's called math practice standards, and this is really what's, I don't want to say forcing, but developing all those things we talked about, the coherence and the deep understanding. So these are not about what content they will do, it's about how they'll do it and what they'll be able to do with it. And these are pre-K, I'll say K because they're based on Common Core, through high school. So these do carry through all the way. So the first one, make sense of problems and persevere in solving them. And then what's in red underneath is what you would say to a student. You obviously wouldn't say, well, make sense of it, persevere. But you might say, a student might say to themselves, I can try many times to understand and solve a math problem. So, not having them give up, having them, maybe try a different approach, or maybe they get an approach and they're successful. Can you do it another way? Can you think of another way that you might be able to do it? Reason abstractly and quantitatively. So to students, they might think to themselves, I can think about the math problem in my head first. So it's really about making sense of the quantities and thinking about, is the number going to get bigger or smaller? I can actually give you an example from a high school question. It was a graph of the value of a car over time, so a decreasing graph. And it asked for the value after 10 years, I'll say. I'm not sure exactly how long it was. And students were giving answers, $1 million. $75,000. I was like, well, I want that car. They weren't reasoning about it. It was just a process. It was a linear relationship. They were plugging numbers in, and they weren't really thinking about the situation. So that practice standard encourages that. Number 3 is to construct viable arguments and critique the reasoning of others. So as far as students go, they can make a plan called a strategy to solve the problem and discuss other student strategies too. And that's,
I have a good example of
yeah.
that one. So we do problems at the beginning of the class, and the kids do them, and then I have them, sometimes I'll have kids come up to the board, and I'm like, show me how you solved this. Let's show everybody. I said, you get to be the teacher, you get to explain it, and sometimes the kids are arriving at the right answer, and other times they're not. And so the other students in the room would be able to say, oh, well, it looks like they made a mistake here. And that's huge for kids to be able to do that. And I know for some students it might be hard for them because they're like, oh, somebody's saying that I'm doing something wrong. But the whole thing is a learning process, whether you're the one that made the mistake, the one that's fixing the mistake, or the one that pointed out the mistake. All of those things are so important and so vital to be able to, again, just continue the learning and to really just internalize it and being able to apply it in these different situations.
I think even the example of Jill looking at that problem with the pizzas, and it had a slight error on it, and her being able to pick it up and discuss it with the student about why that's an error is an example of that.
And typically I wouldn't. I would just say, there's a mistake there. What is it? And let the kids really decipher it and look at those small details that are important parts of solving a problem when you're asking to put a label on it, something like that.
So number 4, being able to model with mathematics. So for students, they can use math symbols and numbers to solve problems. They can apply the math they know to solve problems arriving in everyday life, society, in the workplace. So they're not just learning math for no reason, they're actually applying it to different situations. For number 5, they use appropriate tools strategically. So they consider what's available to them when solving a math problem, and they're able to use technological tools to explore and deepen their understanding of concepts. For, oh, I page. For number 7, look for and make use of structure. So for students, I can use what I already know about math to solve the problem. They look for patterns and structure and apply them in different situations. Yeah, this is a long slide. And then for 8, they look for and express regularity and repeated reasoning. So I can use a strategy that I use to solve another math problem in this problem. They notice if calculations are repeated and they look for it, that they're able to generalize it. But again, they're not just going through the motions and not thinking about it. They're looking for, oh, wow, I'm doing the same thing over and over again. I can stop here. Or I remember doing this in a different problem. I can apply it here.
And so this is basically where everything comes together. So it's the automaticity of certain facts and being able to apply the bigger ideas. So just like a lot of the other slides, you need to know as parents where they're doing well, where they're not, where they need reinforcement, extra practice, and where they're okay, they're doing what they need to do, and time doesn't really need to be spent on it. And then just practicing with those facts, because as I said before, that automaticity is important. They need to be able to just spit out those addition facts, spit out those multiplication facts, so that they're not getting hung up on those steps when they're trying to solve a deeper problem, like we were trying to, say, find the common denominator for our pizza problem. And then, again, just thinking about it in real life. So even if it's not a word problem, applying it in that way, because that might help your student. Your student might be able to think better when it's thought of, like with an example of something. Use pizza, use anything. Pizza's a big one. Pizza and cookies is a big one that comes up a lot.
Food.
But yeah, food. We love food in my room.
Everyone's more interested in food.
Yeah. And so anything that just makes it real.
Yeah, speaking of food.
Yeah, speaking of food.
We have strawberry milk, but I think just given time, and we want to give you guys a little bit of time for questions, I think we're going to skip this activity, but what we had planned on doing, so this is a problem on a recipe for strawberry milk, and you can see those manipulatives in front of you. Maybe we can just do it quickly. See if you can think of a way to use those manipulatives to represent 5 cups of milk and 2 cups of strawberries. So then what the question is asking them to do is to figure out how many cups of milk and how many cups of strawberries would you need to serve 20 people. So what would you need to do in order to show that? Right, you need 5 sets of those. So you would be able to, and so that covers a whole bunch of practice standards. You're modeling, you're using a tool. Yeah, we were going to go back.
If you were having trouble with it, you'd be trying to persevere through the problem if you weren't sure where to start.
For an activity like this, we'd probably have you working in pairs or groups, so you'd be listening and speaking with each other.
And then we may have a disagreement here because she used the yellow and the red, and you have your piles over here, so there might be some critiquing going on.
Well, there's no ice in it either. I mean, who's going to be drinking?
That's right.
Who wants ice in their milk?
Yeah.
You need to fill it up.
Smoothie.
Yeah, thank you. A little yogurt maybe too.
And then before you guys leave, there are grade-specific handouts over here. We have them labeled, so whichever grade your students are in, you can even grab the grade higher or lower if you'd like. So if you just want to take those on your way out, there's just examples of problems, there's tips for parents, and then there's a little activity on the back that you may want to do at home.
So if we could just take a look at what's in here, just so you know. So it has a summary on the inside, the major work that we talked about, the practice standards, and the fluency requirements. On the back, there's a list of some resources, some websites that can help you. You know, when you're stuck on the math, you can get some ideas. I will say Khan Academy, he does a good job of using the Common Core and some of those practice, those modeling and
I
practice
actually
standards.
personally use that a lot because I'm in a graduate program at Salem State right now, and we're doing things that are like high school level math. So as somebody who's a middle school, elementary person, some of those concepts I don't always remember, and so being able to have those videos where he really walks you step by step are awesome. And then the Common Core sheets on there is a good one if you're looking for just quick resources to use with your students, because they do include answer sheets on there, which I know parents always like.
And then, I'm sorry, on the back, as far as ways to help, I will say that first one, I can't say it enough, that positive attitude. And it is a time of change. It's difficult. that we're not doing math the way you might be used to doing it, but the more you can encourage, I always said, and this was even before, I had this on my brochure that I gave out at Open House even before Common Core, you'd probably never say, oh, I was never good at reading. Oh, I was never good at following the rules. So please don't say I was never good at math. You know, say it was something I had to work harder at, and you know, show them those ways to work. There's also other things about, you know, it talks about the thoughtful question that we talked about and some of those other things. Other benefits of Common Core, a lot of these slides we pulled from resources that are out on the internet. Now that multiple states are using the same standards, because we've always had pretty strong standards, they're even stronger now. There's that shared resource, and that shared professional development for teachers is huge. And then I would say the other benefit is the accommodation. It accommodates a mobile society. So, you know, I had a student move from Florida, and I taught 8th grade, and he hadn't had some of the foundational learning that he needed. So I'm trying to get him caught up. Now, I mean, there's a few states that haven't adopted, but most have. So, you know, we can count on kids coming in with what they know. So, I'm sorry, I'm taking your questions.
It's okay.
Go
I have
ahead.
2 quick questions. One, I mean, I don't have any solutions for either one. But one of the things you said, we were trying to prepare kids for world market with all this on the earlier thing. There's only 3 countries in the world out of 195 that don't use the metric system. So, I mean, how are we preparing the kids for that?
Yeah,
and then
I
also
agree with that.
The kids in college, I had 6th grade level math. I mean, I had the same issues because they implemented some new math program when I was in 4th grade, you know, decades ago, obviously.
Right.
But the kids who are in college with 6th grade math, didn't they go through the MCAS program?
Yes, they would have had to. There is an alternate for MCAS, and I think you can get into a community. It's a community college, so it's not true college level. But from my understanding, UMass Amherst, the UMass schools have the same issue. So, you know, they're coming through with that base understanding. And I don't know if you guys have heard this before, but I was an 8th grade teacher, so I was very aware of it. The 10th grade MCAS is actually easier than the 8th grade MCAS. So, because it's that graduation requirement. So they were really passing through kids that weren't quite at the level that they should have been at.
And I was just hoping to be doing the same thing with Common Core.
Yeah, we'll see.